Okay, everybody, welcome to our evening track of talks. And I would like to introduce our next speaker, Dash from Berlin, who's going to give us some information about hacking embedded devices and what fun to have with them. Dash, you have it. Enjoy.
Thanks. Hello, is this working? Yep, okay, perfect. Yeah, hello, I'm Dash from Berlin. Today we'll talk about embedded devices. You can see that very clearly. Okay, here we go. Embedded devices, you know, it's all those nifty small things you can find nowadays everywhere. You have it in your mobile phone. It is actually your mobile phone, modems, maybe your coffee machine someday, your refrigerator, everything. You can find them, or for example, a NAS, a network attached storage device from EasyBox or Western Digital MyBook. This one, you have routers like the Fritzbox, Siemens Horsebox, Linksys boxes. What's nice about embedded devices? Of course, they are small, so if you want to have a router as a workstation or server, you don't have to put a fucking big thing in your floor or somewhere. They are usually not that power consuming, so that's cool. Usually they're special purpose built, so for example, they have to be a router or they have to be a phone. Actually, there are exceptions you see on the mobile phones. There was a time when phones were only for dialing, but I think that's a long time ago. So the controls on those devices, you usually have not a lot of memory. So let's say the average of RAM you have on... Hello? You want something special? What the? No, it's not what you guys think. No. Okay, so here we go. They got not a lot of memory if you compare it with nowadays computers. So let's say maybe 10%. The device here, for example, has by 128 megabytes of RAM. Of course, it's still much more as your Amiga or C64 had years ago. You will meet strange architectures and CPUs which not very fast, like 100 megahertz or 200 or much slower maybe, and you have by different architectures, you can meet ARM in little endian or big endian, PowerPC, MIPS, so there's a lot. If you want to play with those devices, it will take usually some time until you have a prompt, so until you can really do something with the things to see the inner workings, how everything is done on that. And of course, they have also exceptions. You can own a device like this maybe also in 10 minutes if you find a code execution bug in a web interface, for example. Okay, there are some books. As you see already, maybe here, I will target this talk mostly on Linux. I have them both, and I read them partly. I think they're okay. So for introduction on this topic, it's cool. Actually, they are topics on developing, but you should know some stuff about the developing to reversing such stuff. So, what this talk shall be about is I'd like to give a short overview over devices which run Linux, or at least you guess there's Linux on. So I will not topic BSD embedded devices. You can find them, for example, on printers. No QNX, which is on systems like the controlling for windows or doors and such like this. I saw that. VxWorks. You can find a lot of VxWorks. You can see them on, the newer Linksys boxes, as far as I know, using VxWorks. Phones also have a lot of VxWorks, so if anybody has done some research on VxWorks embedded devices, I would be very pleased if you can drop me a line or just talk to me. I'm interested in that. So I also don't want to talk about GPL violations. There are a lot, of course, and if you reverse something and you think you have a GPL violation, please research further and don't send some crap to GPL violation org. I think so the guys don't have more hassle like checking if this is really a violation and stuff like this, if you're interested in so. Okay, and what you really want to do is void the warranty. So you have this device and it's just in your floor and it's lonely and you really want to open it. You want to play around with that, really. Okay. In January, there's a lot of Linux. So a lot of devices, some are GPL, I said that already, maybe not that expensive. I already said, what the hell? What the fuck? Okay, nice. Yeah, Go developer in that could be very, very cool because you can make your own stuff with that, and there is some documentation. Okay, partly the toolchains, they're hard because you're downloading a toolchain like from uclib.org, so you can compile it for different architectures. But I don't know, anybody in here use that already? uclib, C, downloading stuff, and does it work from the first time if you try to build environment for cross-compiling? Huh? Yeah. Yeah, it's really hell. It's nice that the guys are developing on this, that they do that, that's great, but it's a pain. It's a real pain. Okay, so we will have a lot of fun with that. Okay, let's talk a little bit about security on bytes embedded devices. Usually they're not that tight because, I mean, who's playing with them? I mean, usually customer just put it in the floor or somewhere and that's it. You will never have a look on that, right? You can find bugs everywhere, I guess. There are a lot. For example, you have still input validation or input filtering stuff. So if I remember correctly, there was the first way to have access on the Linksys via grouter was through input validation bug in the ping field. So you could put some semicolon there and do an ls and you got command execution. Okay, what's about buffer overflows and the protections? Of course, you also have buffer overflows there. Of course, you have a different architecture. So you really have to investigate this architecture and what you exploit, see if it's working. But however, I haven't seen still now some GR security or SLinux on embedded devices. Maybe there is, maybe someone of you saw it already. I don't know, maybe it's even not working because of different architecture. Okay, and another point of the security on embedded devices you buy, how the hell do you make updates? I mean, you buy this thing and you have it at home and there's maybe one firmware, and even if when the product was produced and was new, even then it's pretty usually that it's very outdated already. So you find Linux kernels from the last century in there. Yeah, so you have also the security crash. You, as I said already, you have a lot of memory, it's not that fast, so the CPU, and you just can send crap to the device and it will freeze. So not everything, of course, but that's bugs you usually came across if you play a little bit around with embedded devices. Okay, yeah, there's another funny thing about those embedded devices. The backdoors you can find if you do that. Still my personal favorite is the Netgear backdoors, which were in some wireless access points where some guy just found it out, sent it to mailing list and sent it to Netgear, where the default user account was super and with some password. And then they made a new firmware and they changed that. So super goes to Superman and you had a new password. So then there was something about Aruba, which some guys from Entrance, as far as I know, found out. This was also very funny because Aruba seems to be like a big company business shit. So you maybe some bank or some government or military guys are using those devices and they seem to be full of crap. So like hard-coded passwords, some stuff like this, overflows, and so on and so on. And there's another thing I really liked, which was a British provider who had his own modems and was giving them to the customers, and some other guys just figured out, oh, okay, there's a default account. And with the default account, I can access all the routers from the other 50,000 users here in Great Britain. Great, I like that. Okay, so now to get a little bit more practical, what you can do to have access or get access. Of course, you can try to fiddle around with the firmware. What happens, what used to be happen is that you have been running software on the embedded device, you have hidden comments, you have to figure them out. You can do that, for example, by using some security scanner for web, for example, if the target is a HTTP daemon, or you play around with that, with the scripts. Or you already had the firmware reverse and looking then in the directory of the server and looking there for scripts and backdoors and whatever. To get access, you can also, or you should look into the software you get delivered from the producer, because there's always some stuff into which can be very interesting and gives you a very good idea how the embedded device itself works. JTAG interface. I mean, guys who are doing that are very skilled. Respect. So if you have access to JTAG interface, if you soldered it on the board or something like this, and it's still working, that's great. Serial interface. There are some boxes, like for example the Horsebox Professional, which has a serial interface already on, so just connect it with your Minicom, CU tip, whatever you have written, connect it, and you get a prompt. Sometimes there's some parts on a board left where you could solder a serial device onto, and you can do that, but you should be careful with that, because you know, burning your main board, burning your hardware is obviously a bad idea. So if you do that in the first week here in Germany, and you bring it back to the place where you bought it and said, oh, sorry, it's not working, that's maybe okay. But afterwards, you may be screwed up by $300 or $200 or $100 or euros, and you're fucked. And you come up maybe with the one big question everybody had already: what will you do? I mean, what do we know? It's fuck. Okay, so here's one nice example of what you can do, what kind of steps you can take. The RV42 is a router from Linksys. It's a VPN router. You can buy it here over at Saturn. Yeah, 200 euros, 2419 kernel. OpenRG is some Junger's things, I guess. So processors into scale, everybody can see that. So when I buy that device and play with it around with a short time, what you usually do is a port scan, because you want to check for the network connections. And of course, you just have no remote control. You have a HTTP server you can access and read it and configure the whole box through it, but you can say, just give me a prompt, please, because I want to have a shell on there, and I want to play around and want to see what you are doing. So I just tried out the software they delivered. They had an updating tool, so for the firmware, of course. And yeah, I started that, and you have to put your username and the password into there and say, yes, please update. And then it goes there and talks to the box. And while I was doing that, I was looking on the network dump of Wireshark, and it was connecting to port 23, which is obviously the telnet port. So it had get 2 resets, and I thought, okay. And then there suddenly was a handshake, a TCP handshake. And then there was a reset, and it was closed. And so I tried after that, okay, what hell is that? And I tried, okay, the port is closed again. I tried it another time, and it was the same. So I investigated a little bit further and looked into the dump, and what was going on there. So this was sent from the tool, from the firmware updater tool to the machine, which is this info 123 HTM, please console emulation, simulation. Simulation, okay. And it answers with, hello, I'm that, and I model name with friendly greets, support console simulation. Yeah, and this simulation actually is telnet. You can log in there, and then you have a nice shell and can start with playing around with that. Yeah, it's a Jungo OS on there. I have no idea. I just had a short look into it, and you can download that and you can play around with this, or you just use your custom toolchain for developing stuff for that. One thing, this router is, so there's not a lot of memory. It's pretty small. I think I had by 40 KB or so left. So you have to do that some stuff. Okay, IZBox, NAS 1000. Yeah, network storage device. This is a really nice example of what could happen. So I got that box. It cost by 100 euros or something like that. And I just got the firmware somehow. I guess it was on a CD, and I played a little bit with around and uploaded it, and guess what? It never come back. So, and then there was one thing which saved me by 500-600 meters to the media market to bring it back and say it's broken. I thought about MacGyver, and if there in this movies there would be internet, you had to look at it. And I did that and figured out that there was a guy already who completely reversed that stuff. And he made already images for this, and he brought me to something I never knew before that, which is, right? No? Yes, Red Boot. Red Boot is a cool bootloader some embedded devices have. I think it's from Red Hat or something like this, and you have a short time frame by 3 or 4 seconds maybe. What the fuck? Okay, here we are again. Okay, so you have a short time frame after the power on to, yeah, talk to this bootloader. Yeah, that's what you see here. So, ping, and then port 9000, and then please press Ctrl C, and yeah, then you have this nice boot menu, which is pretty cool. You can go on, just show me the images, delete them, and you can upload them. You have an overview, what is where, and if you have a TFTPD on your favorite operating system, you can upload the stuff. Yeah. And as long as you don't fudging around with the bootloader, you can play around as loud as you want and it should work. So no crash and bring it back to the market and say it was broken. Yeah, so you don't have to do that. Okay, yeah, so firmware where you can get it, Find the file system, that's important, that's something you really want to do if you start to reversing that. Okay, so for doing that, I will give now a short overview about the file systems you will run in, or you pretty sure will run in. So this is, first one is ROMFS. Yeah, as all, there's a small file system, it's read-only, so that means if you mounted that already, there are some people, I guess, which tried on all those file systems to hack around and just have their modules to maybe interfere with those file systems, but I don't know if this is working. However, what you can do is every time just play around with your hex editor in the file and see what happens. Yeah, what you don't have is modification dates, so you're every time in the 70s, so don't wonder about that. You got no Unix permissions, written by Farkas. You can read about that at ROMFS SourceForge. I've stolen this from the description of it. Yeah, pretty obvious what it is. If you have a firmware where something like this is stated already somewhere in with ROM 1FS and stuff like that, pretty sure ROM file system, pretty sure. And yeah, the size, the checksum, volume name. All of this stuff is usually very important to know. So at least you should check for that. Because if you're playing around with the firmwares and building your own and want to bring up a new firmware to that device, you maybe have to figure out what steps the developers of the company of these products took to stopping you from doing so. So they maybe have a crypted password or something like this in their volume name. Or they are checking for the checksum and stuff like this. And if this is not correct, just the firmware upload tool will forbid it. And yeah, so I've won nothing. This is an example how it looks like. So you can see it pretty clearly again. ROMFS test image, that's the name. There you have the size, which is like here, but okay, my arms are too short. SquashFS. It's one of the. It has a lot of options. It's the mostly. Yeah, it's so long list, and you can do a lot with it. You have gzip support, SMNA, it's also read-only. You have UIDs and creation time supports. You can detect duplicates, and yeah, can from the beginning start to say, okay, I want to have it in a little engine, or I want to have it in a big engine, I want to have some inodes, whatever. Yeah, that's how it looks like. I go on now. ChromeFS. What's so funny? Tell me. Shall I go back? Something? No? Okay. Yeah, I will not read the name. So it's read-only, and it's also a small one. So it also has no Unix permissions, and there's also no creation time, as far as I know, by now. So here's the example. I mean, because of the ASCII screwing with the compressed ROMFS, you may run, you can't oversee that. So overlook that. But it starts some bytes before, so with the big E, so with the 45. Yeah, and there you have the ChromeFS image itself is the name of that, and yeah. But you can't miss that in a hexadecimal file. Or a file. So, okay. I wanted to talk about some device I can bring here, and I thought about doing some routers, but there's a lot of work there's also a lot of work done with them, like with the Fritzbox. And if you're interested in those boxes, just check Google or whatever your favorite search machine is, because you can find a lot of stuff like how to get a shell on a Fritzbox with just uploading a shell script and stuff like this, or enable it through your ISDN phone if you're directly connected to that box and stuff like that. So I will talk about a little bit about this PBX from LMAC. That's this thing here. Oh, I can put that. Here you go. I think only I have a photo, so you can see more about the internals. Yeah, it's from LMAC. It's now called Funkwerk EC. Besides ISDN and analog, you have also router functions, so you can connect it to your local LAN, and you have INET access and stuff like this. I mean, I miss this whole PBX thing. So that's, I think I'm too young for that. So the whole war dialing stuff, and so I never was really interested in PBXs. So during working with that, I recognized they have a nice option legally in their handbook, which says, okay, if you type this and do that, you can observe and record everything what's going on in that special room via telephone. So what you have is a device, you just say, okay, I want that room 101 is completely observed by, and the voices are recorded to the compact flash card, and you can start that. That's, yeah, something I never knew those such things can do. Yeah, what the internals? You have the P1001 Colibri processor on it. I have no idea. I haven't read the specs yet. Just know it's a 32-bit processor, and yeah, some PC cards, some slots, whatever slots there are. Okay, that's a photo of it. So here the processor, some memory. Here you have the compact flash. This looks like a little bit of a PC card, and yeah. I don't know if you can see that good, I hope so. And yeah. Okay, how to get a firmware of this thing? Okay, there are two ways you can do that. Look at Funkwerk, and then you have the FTP server, where you have three more firmwares you can download. The point is, if you do that, and you download them, and then you look at them, and you wonder why, because obviously, they had a problem with typing things. So there's a firmware version which is version 113, and then there's a version 131, which is obviously the same archive. So they have that on their FTP server, and go for it. Okay, now comes the first short demonstration of Fin. Fin is a firmware inspector written by a Polish guy, SQ5BPF. And what's cool about this tool is you can automatically extract things Fin found. It works like you say, yeah, go for this file, check what is in there, and it tries to extract it. Okay, that usually it can extract it, and then it tries to, for example, gzip it or unzip it. And if it worked, the file stays. If not, it wasn't that kind of file. So let's see. Debian. Yes, Fin. Verbose, no. God damn it. Input file. T. Output. So, this should work. This should work. So it's a little bit slow. So now you see it tries to read all the stuff and take some time. And okay, then you say ls, and you got a bunch of gzip files. That's interesting, and you go for one file. And this is usually the case. So when Fin says that's something like this, then it is really a gzip file or something like this. So there's no real false positive with that. Demo, no, demo. Okay, there's crap in the ending, that's usual. And okay, so looks like some kind of cult Linux, right? I mean, that's pretty obvious. That's Fin. What's bad about this tool is that you still have, God damn it, not so many file types or stuff like that supported. So, but I heard rumors that there will be more in the future. Okay, UV Firmforce is a tool by Corbin from Uberwall. It's a very cool tool. And you have a bunch of implemented file systems. You have a scoring algorithm where the tool says, I don't know, maybe this is kind of file like this. So currently the web page is down, but it will be online very soon as far as I know. It's online? Okay, no, forget what I said. It's online. If you're interested, get it, it's cool. Here the UV firmware example. Okay, it's pretty simple to use. You can say this that. And unfortunately, it has not yet this mechanism to extract stuff automatically, but maybe that will be implemented someday. Okay. I give you a week. Okay, and that's something really cool. So UV firmware was recognized very soon. Okay, here at this offset, there's maybe some ROM FS. Okay, it's pretty sure about it, I guess. By 100% is the score. Yeah. So you can go for that in that case. You just say, hello, give me that. One image, 65. Skip it one time, it gets extracted, you mount it. Okay, maybe you can do a file before on that to be pretty sure it is a one. Oh, okay, it's a ROM file system. So let's see. Mount point. Okay, it's mounted, and here you are. So you have the file system of this box here, which should be the actual one, and you can start to figuring out what's going on there. So you have Linux bins, which is obviously the kernel, something like this. But okay, and you can have a look into it. Yeah, and there you go. It's Linux version 20380. Nice. But it's from that century, so in general. That's nice. So then you of course can check for, you really want to do that, you really want to check for the binaries, the S-bins and stuff like this, because you want to know what's going on there, because you maybe want to find another way into that box, you maybe want to find bugs, you want to know how that works. Yeah, and then as usual, everything is linked to BusyBox, small interface, it's cool. Yeah, and then you get to see something you never saw before. You see BFLT executable, version for ROM gzip. I think I will come to that very soon. Stay tuned, okay. File. What else? Yeah, okay, that's what you need. You want to have tools like strings, hexdump, hexedit, hexer, whatever disassembler you like to use, your scripts you build for that purpose, something like this. Okay. The internals of those firmware. Wait. No. Exit it. Okay. So this is a header, pretty obvious. And at this stage, here's some kind of checksum. I'm not very sure what this is. If anybody already did that, please tell me how is it generated and so on. I mean, it could be a CRC 16 or a 2.8. I have no idea. Pretty unsure. So from this part, the firmware is uploaded to the system. Here you see some kernel options. Yeah, okay, here. Here's the padding, and here the ROM file system starts. There's no magic. That's all about that firmware. How much time do you have, by the way? How many? 30? Cool. So I will slow down now. Nice. Okay. Yeah, what's next? Now, okay. From a security point of view, I mean, there are usually you know, like it is in the capitalistic work. Everything has to be done very fast because it has to be put on a market and you want to buy it and then you need a new one and everything has to be very fast and nothing is done very well usually. So you will find stuff on the device which should not be there. Like, why the hell you as a usual end customer want to have a GDB or GDB server on it? Right, it's cool for us. It's nice, it's already compiled, you don't have to do anything, that's cool. But it should not be there, actually. You may find some development scripts, yeah. However, for reversing or hacking stuff like this, that's pretty cool and you want to have that. So please don't change that. Okay, now I come shortly to BFLT. We saw it already. BFLT is some kind of file format and yeah, the binary flat format or I don't know. You will recognize it already on the BFLT in the header, so that's very obvious. As I wrote that it's based on a out format, and what's pretty funny is, or cool, is you can pack that with zlib. So that's actually what the firmware inspector I showed some minutes ago had found. That was all the binaries which were zipped, so with gzip. Yeah. Unfortunately, you need to have the special option compiled into your kernel and to have the library to execute those. So you cannot just take these binaries and put it to your custom own compiled environment without BFLT support and execute it. This will not work. Yeah, and if you want to go into the bloody details, which are not that bloody, behind logic. I mean, I can show you that. So, full screen, force, mount point, cp bin. Okay, let's take BCCD. That sounds like something which should belong to that place here. CU. Yes, I'm off. Okay, so, and yeah. Now I already know that this is at offset 64, it's gzip format, but I can just show you just for the protocol. This should work, and it says offset 64 gzip. So you just go again with this nice tool, which is called DD, and go to here and say off bccd zip 64 skip 1, and then you uncompress that again. Hello. Yeah. So that's gzip. That's pretty cool. I never know about that. Yo. Okay. Let's see. Yeah, I already said something about the deliver tools when I was showing the example from the RV42. You really want to do that. So you really want to know how everything is working, and so you want to use, yeah, for static or live runtime analysis like Oli debug or AIDA, if you like that. For network analysis, you of course want to use some kind of Wireshark or TCP dump, or yeah, and you can find funny things with that. Yeah, Wirequark is nice. Okay, so I will show some. Some thing from this PBX, how you can find it in a network. So, how does it work? You set a broadcast to port 5000, and with a pretty unsuspicious string, detect router and LAN by LMAC, and they will respond like, here's an LMAC router. That's pretty cool. I mean, it's like detect lady in local room and or something like this. That's great. And I found that by just looking at Wireshark, and there's no magic in doing that. You just have to watch for the traffic. So Here's the find. Okay. Here we go. Find AMAC. And there's a Python script. Find me. Send it here. So I think that's the time. I think so. Okay, and yeah, that's already your answer. So it sent it out, and then your answer comes back. Hello. That's me. Yeah, that's the stuff. Get the logs. You have, usually, what you can do is like because you have the problem that most of the tools just run on Windows, so you always have to have a Windows for stuff like this. And then you just observe the tools. So this is one of the, what is this one? Yeah, this is one of the tools of this, which checks all the time if it is connected. Please don't wonder about this here, it's just crap. It's just when I tried something and it's a provider name. And yeah. And then you can just put here some buttons and it will do magic in the background. Oh, you say establish, and yeah. But I recognize this will be the next slide. So I want to show you something different, which is the system messages. Yeah, so now they are gone. Hello? Here we go. Yeah, this is yeah, pretty obvious. You can connect to the device and get the messages back from what's going on there, and this helps also if you start to reverse the stuff. And yeah, if you look on the network, you just see there's no authentication, no nothing. It's just a simple syslog daemon, and you just can connect there with your neat Python script. And yeah, that's especially for you. It's Christmas time, you know. And get logs. Python. I think that's yeah, right. No. Ah, yeah. Okay. Now the time in which. Yeah, I can do that. Wait. What? Okay. Nice. Okay. Okay. So that's all. Then you can just connect there, and okay. Now you have a nice monitor for Linux, Unix, whatever box, and you also can observe it how it crashes and stuff like this, or when it boots, and you want to have something like this. Really. Okay. Then there's another thing, which says where you can get the status. That's simply that. So there's also no authentication. That's actually what you saw here, the other thing with the provider information. You saw that. I don't have to show that again. And there you just send a symbol to the device, give me a start request, and then you get all the information back. You can also dial through that port. So you can say, please dial that and go for that. Hang up. So dosing the network the whole time, you know, like hang up, hang up, hang up, hang up. But it makes no sense because you want to go through the internet, so you shouldn't do that. And I can just show you that. No, we leave that. No. Yeah. And that's all. So that's what we have seen in the other window. It's like here the provider and what's going on with the device. Yeah, that's it on that. Yeah, BCC. Seems like those guys know already that I will do that talk here. I call it just BCC protocol. So that's a BCC protocol. That's what's running on this system. If you connect to one of the more interesting ports, which is port 5000, and if you look at the network dump, you will see in every header the whole time BCC. No. So it's a binary protocol, but it's not really encrypted. You have sometimes some ASCII in there, so there's no encryption. That's also very cool. Yeah, what I've done is, so you can do the version checks with that. So what version is running on. You can, of course, figuring out the passwords with that. And yeah, you can upload the firmware, up and download the configuration with that. That's very cool. However, I'm not finished with that, but with the firmware, I will talk about that later, I guess. Okay, bugs. Bugs on that device. I just had some days for that, so I started with that 2 weeks ago, and so I just scratched a little bit the surface of this. Of course, the professional configurator, which is the name of the Windows tool, it crashed. If you start to fiddle around with the network packets, like in the update mechanism, so I wrote my own T484 emulator. So if I try to upload on my Unix, so I can run it there, and so if I try to upload a firmware, for example, I connect it to this emulator, and then I see what's going on, and yeah, if you send some packets, the professional configurator not just don't want I have this package, it just crash. Yeah, and of course, as usual, you can crash services really easy because they may be bad written, there's not enough memory, memory leaks, whatever. So, okay, that's mostly it. Open items. I haven't finished the upload mechanism, so I have to invest there some more time so I can bring my own firmware on the box, which still hangs on some checksum stuff I haven't figured out yet, which really sucks, and exploit some bugs. FX said it yesterday. I think Dan says it the whole time. It would be really, really great if you had some tool to picture binary data and picture exactly firmwares and stuff like this. It would be great. Like if you see, you have pink, oh, that's ROMFS. You have green, yes, SquashFS, and binary data looks like this, and so on. Yeah, during the Beyond Caribbean Island would be also nice. Okay, I think that's mostly it. Yes, that's the thanks part. And I hope I haven't missed anything. Thank you, I'm done. Are there questions?
Hi.
Hi.
Thanks for the nice Vortrag.
Thank you. Thank you that you like it.
When exploiting boxes that are running on Linux, do you usually only modify the contents of the file system, or do you also modify the Linux running on the boxes?
You can do both.
Yeah? Is
Yeah,
that
of course.
easy?
Huh?
Is that easy to do?
No.
Okay.
No, I mean, the main problem on that part is that you don't want to crash your device, of course. And if you don't have a developer board, I mean, you have to be very, very cautious with that. So you maybe can just, if you really want to own some such thing, you have to get a developer board with the same configuration or something like this and test it, or you try to retest it in something like the emulator, which is working on Windows, and you have to compile that for Unix, where you can just play around with the Linux kernel and the binaries in GDB, which is pretty cool. And so you have to retest it, but yes, of course you can do that.
Okay. When will your slides be available?
I think end of January maybe, something like this, maybe in the middle, so but not before January.
Thanks.
Okay, thank you. Any more? No? Everybody's happy? Nice. Okay. See you.